You know how you meet someone and you're just shocked when you find out their real age? Maybe they look a decade younger or, maybe a bit older than you'd have guessed. Well, today, we are going to get right into the science behind why that actually happens.
So here's the thing. We all have two ages. There's the one on your birth certificate, right? The one we celebrate every year. But there's also this other, kind of hidden age that tells the real story of our health, right down to the cellular level. And in this explainer, we're going to decode the fascinating science of that biological age. And we're going to focus on the most visible organ we have, our skin.
All right, first up, your age versus your skin's age. Let's talk about these two clocks and start to unravel this whole mystery. I mean, we all know that person, right? The one who just seems to defy time. So, is it all just about winning the genetic lottery? Or is there something way more complex going on at a molecular level? Well, the answer really lies in understanding these two very different clocks ticking away inside all of us.
Okay, so let's break this down. Over on the left, you've got your chronological age. Super simple, right? It's just the number of candles on your birthday cake. But on the right, that's biological age. And honestly, this is the one that really counts. It's the true age of your cells, a reflection of your overall health, your lifestyle, and it can actually be sped up or slowed down.
So, to really get a handle on biological age, there is no better place to start than our own skin. We're going to decode its story and look at something called the exposome effect. Just think about it for a second. Our skin is our outermost organ. It is literally on the front lines, facing the world day in and day out. And that makes it the perfect window into our aging process, because it keeps this visible, running record of everything it's been through. It's the perfect illustration of what scientists call the exposome. So what is the exposome? Well, think of it as the grand total of every environmental hit you take throughout your life. UV radiation from the sun is, of course, the big one, but look at this list. Air pollution, tobacco smoke, your diet, lifestyle choices, even stress. All of these things leave these tiny molecular scars on your skin. They are exactly why one person's biological clock can tick way faster than someone else's.
So how exactly do all those environmental factors change our skin on a molecular level? Well, for that, we have to go a little deeper. We need to look at our epigenetic software, the instructions that are actually controlling our genes.
Okay, the key word here is epigenetics. The absolute best way to think about this is like a computer. If your DNA is the hardware, the physical machine, then epigenetics is the software that tells that hardware what programs to run. It doesn't change your actual DNA code, but it decides which genes get switched on and which ones get switched off.
And one of the most important of these epigenetic switches is a process called DNA methylation. Now, don't get bogged down by the diagram here. The main thing to get is this. Tiny chemical tags can literally attach themselves to our DNA. You can think of them like dimmer switches on a light, They can turn a gene's activity down or just switch it off completely.
And this is the absolute kicker for skin aging. As we get older, our skin starts to accumulate more and more of these methylation tags, and often in all the wrong places. This process actually silences the genes that are responsible for keeping our skin firm, plump, and youthful. Basically, our youth genes get switched off.
So, if our true biological age is written in these super complex epigenetic patterns, how on earth can we read them? Well, that brings us to the next part, where artificial intelligence steps in to build a skin clock.
Scientists have been working on this exact problem for years, and the solution required a massive breakthrough, one that combines deep biology with the power of AI. And that led to the creation of what we call an epigenetic clock. Now, building a skin-specific clock like this is a huge project. First, as you can see, you have to collect hundreds of skin samples. Then, scientists analyze the unique DNA methylation patterns in every single one. After that, they feed all of that data into an AI model and train it to find the specific patterns that are related to age. And finally, of course, they have to test the clock on brand new samples to make sure it's accurate.
And the sheer scale of this is just wow. To build one of the very first skin-specific clocks, researchers analyzed a mind-boggling 850,000 different methylation points for each individual skin sample. That is a mountain of data that only a really powerful AI could ever hope to make sense of.
So, what's the result of all that incredible work? A remarkably accurate tool. You see, older, more general biological clocks, they really struggled with skin. But these new, specialized models, they can predict a skin sample's biological age with an average error of just under 4 years. In the world of molecular biology,
That is a massive leap forward in precision.
Okay, so this is way more than just a cool science experiment. This technology is a total game changer for dermatology and the beauty industry, which brings us to our next section, testing the anti-aging promise and seeing how this tech goes from the lab to the product label.
I mean, seriously, for decades, this has been the million-dollar question, hasn't it? We always had to rely on before and after pictures or really subjective claims like skin feels firmer. But how do we get cold, hard, objective proof that something is actually working on a molecular level?
With the skin clock, we finally had the answer. For the first time, we can test a product, we can test a treatment, and we can measure at a cellular level whether it is actually turning back the biological clock of your skin.
And this isn't science fiction. It's already happening. Just look at these real-world examples. Scientists tested an ingredient called dihydromyricetin, or DHM, and they found it could actually reduce the skin's epigenetic age by about 2 years. They've also shown that things like laser resurfacing can literally reprogram the skin, resetting those methylation patterns to a more youthful state. It's incredible.
This quote from the scientists who developed the clock, it just says it all. You can't optimize what you can't measure. For the very first time, we have a standardized, objective yardstick to measure the molecular age of skin, and that opens the door to truly optimizing how we care for it. So, what does all of this mean for us, for you? Well, our final section looks to the future of skin science, because we are right on the edge of a brand new era of personalization. The future is all about personalization. I want you to imagine a skincare routine that's tailored not just to your skin type, but to your skin's actual biological age. And getting that reading won't mean some painful biopsy. Nope. Researchers are perfecting non-invasive methods using simple tape strips. Plus, this tech is going to dramatically speed up the discovery of new, effective anti-aging ingredients, getting them from the lab to our homes faster than ever.
And that really just leaves us with one final thought. This technology is moving out of the research lab and it's becoming a reality. So the question isn't if we can know our skin's true age anymore, it's what will we do when we find out? Would you change your lifestyle, your skincare? It's a pretty fascinating future to think about.